So normally following the technical plenary, we have a keynote that is more of a technical nature. And so I am absolutely delighted to introduce our technical keynote. You audience, dear audience, are in for an absolute treat. It is my pleasure to introduce Xan Fredericks. She goes by Xan. Xan is the National Map Liaison to Florida, Puerto Rico, and the U.S. Virgin Islands for the U.S. Geological Survey National Geospatial Program User Engagement Office. And she serves as a Geospatial Information Response Team Operations Officer. Now, this has come full circle from when she was in high school and before that, but certainly there was a formative time in her high school experience. This was right before her senior year in high school, when she and her mom lived in their van in the Florida Keys just so she could spend the summer volunteering for the Mel Fisher Maritime Museum. And at the museum, they let her work on artifacts from an actual shipwreck, scrubbing the cannons and piercing together pot shards and other fantastic work. Is that cool or what? So this was a formative experience for Xan. Now, she is the National Map Liaison to Florida for the USGS, and she works to help people from USGS scientists to our nation's residents all across the country to a variety of agencies and entities to discover and coordinate geospatial data to empower location intelligence through outreach, collaboration, and data visualization. And this is one of the reasons why we wanted Xan so much to present this technical keynote. Now, Xan does a whole other spate of wonderful things to serve our ocean weather and climate community. For instance, she's the chair of the USGS LiDAR user group, and she's a member of the Interagency Working Group on Ocean and Coastal Mapping. She has a lot of involvement with the ASPRS, with URISA. She's on the board of directors of URISA and serves as the board liaison to the Community Resilience and Professional Education committees there. Xan was trained at Eckerd College. She took a BS in Marine Science Geology from that great institution and a Master of GIS from Penn State. And she's also a certified GIS professional. And finally, in 2021, the U.S. Geospatial Information Response Team received an Esri Special Achievement in GIS Award, and she was part of that team and has also been named as a 2021 Geospatial World 50 Rising Stars designation. So it is my absolute pleasure to introduce this rising star, Xan Fredericks. So Xan, the stage is yours.
Thanks so much, Dawn. And what an honor it is to be with all of you, learning more about how GIS can support ocean, weather, and climate research, because you're connected right now. So you must care about our world. As you said yesterday, Dawn, we're taking it personally. You want your work to have an impact and you want to share your story. So I'm eager to share some of the work of the USGS Geospatial Information Response Team, as well as user engagement, because we know our world is at risk. The USGS uses GIS to help reduce some of those risks. Together, we can help with response, mitigation, even hopefully the regeneration of our world. And we can do that by leveraging the common language of maps. We can connect the dots through coordination, collaboration, and communication. Coordination is such an important aspect when you're trying to connect the dots. Imagine drawing 3 dots on the screen. If you have a piece of paper in front of you, go ahead. It's a vague request, but simple. Were your dots drawn all in a row from left to right? Or maybe from right to left? Or did you draw your dots in a column from top to bottom? Or bottom to top? If we wanted to visualize your dots geographically, were they drawn coming from the west or from the east, maybe from the north or the south? Or did your dots represent elevation? We need more information to have a better understanding of your dots and what they represent. We need more data, especially if I now ask you to connect your dots. Another pretty simple request, unless we want those connections to be meaningful, in which case we really do need more information. We need more data. Now, you're probably thinking, sure, more data would be great, because how do you mitigate a mystery? Well, you make it less mysterious, but there may still be limitations. Limited budget, maybe limited time, or maybe you're limited by your staff size. It's important to stay within budget, keep projects on time, and all with the staff you have. So if you're looking for more data, maybe someone else has it in your area of interest, or they plan to collect it and you can share, or maybe you can split the collection or the cost. This is where coordination can really shine. I'm part of the USGS Geospatial Information Response Team, or GERT, and our core team is made up of members of the National Geospatial Program's User Engagement Office. Lance Clampett's our chair, Chris Cretini is our deputy, Eliza Gross, Cindy Rachel, and I are in operations. What's great is that our knowledge and skills are complementary, so really it's an effective team. During response efforts, we expand the team to include a variety of subject matter experts who help us coordinate across projects, mission areas, regions. Sometimes we even coordinate with other agencies. If you think of the USGS data, products, services, research as tributaries, I like to think of the GERT as the delta. We're accumulating and collating and disseminating detailed information that can be used to better understand and anticipate the risks of hazards, which supports risk reduction by enabling decisions based on science. This can reduce the impact and enhance resilience. The GERT's main products are the event support maps that allow us to compile geospatial data and tools from across the USGS as well as from other agencies, and this helps hazard response and disaster mitigation. These event support maps, or ESMs, are a variety of story maps, web apps, dashboards, and we've organized them using ArcGIS Hub. We create ESMs for internal use within the Bureau, partner use with other federal agencies, even external use for the public. Here we have those created for internal and partner use that require login through the DOI Landscape Decision tool in ArcGIS Online. These include the 2021 ESMs, such as water and the high watermark dashboard. Let's click on that one. High water marks after river and coastal flooding events can be used to support future flood forecasting and predicting the severity of those future floods, and also for delineating the FEMA floodplain maps. The multi-agency high watermark planning dashboard facilitates coordinated collection among the participating agencies, and this lets us increase data interoperability while avoiding duplicating effort. And it's extremely important to field team safety, especially when there's limited access to an area after a storm. The planning can really increase overall efficiencies. Now, this dashboard leverages Experience Builder and uses a notebook to run a Python script every 2 hours during and after an event to capture AHAB's flood stage readings from the NOAA National Weather Service. A feature layer of those data is created to aid in planning the high watermark campaigns. Right now, the dashboard only has a tab for Ida, but if other storms resulted in additional campaigns, we could link them here. This is coordination between FEMA, Army Corps of Engineers, NOAA, USGS. On the left, the flood stage readings default to the current day and current conditions, and they are displayed on the right, showing the major, moderate, minor, and action stage counts. We also provide the count of high watermark indicators by agency And on the map, we've got those symbolized by colored circles. So let's turn those off for now so we can get a better view of the USGS storm tide sensors, which are symbolized by the green diamonds. We could also filter the flood stage readings to a specific date and time. So let's look at Hurricane Ida's landfall on August 31st around noon local time. Now, we could continue to step through the day using the time step filter to assess the change to all the flood stage readings on the right, which is what I'm doing here. Or we could click on a particular stage and use the pop-up to assess recorded heights. Let's zoom in on the storm tide sensors. Here's one near Slidell, and by clicking on it, a pop-up provides more information. And if I continue to zoom in, world imagery appears. Now, by clicking on the imagery, I'm provided metadata that informs me that it was collected in 2020. If I were interested in storm response imagery, I can enable those layers, including gray sky nadir and the imagery from the NOAA National Geodetic Survey Remote Sensing Division's response flights for the impacted areas. The flight on September 1st seems to have captured the area around this storm tide sensor. I can turn the high water marks back on to have better situational awareness of what's been collected and where. Here's a USGS high water mark and an Army Corps high water mark. And as we zoom out, we get a better feeling for the distribution of those high water marks. The red circles represent the marks collected for the Army Corps' New Orleans district that we ingest as a feature layer. Now, Ida didn't just dissipate after landfall. So let's filter the flood stage readings to early September, when she marched northeast and caused devastating flooding. And we'll pan that direction. USGS water science centers in Pennsylvania, New York, and New Jersey received a FEMA mission assignment for a high watermark campaign, and those marks are represented by the green circles. Now, let's say theoretically it was safe to travel to visit a colleague at the National Park Service Sandy Hook unit, and while there, I could collect a few high watermarks. This dashboard allows me to submit a high watermark collection plan using Survey 123. So we can share our plans with other agencies. First, I'll zoom to the area of interest. Once I've identified it, I can outline the target area for collection of high water marks by drawing a polygon on the map. I'm even provided the perimeter length, an enclosed area. Next, I'll choose the event ID, so the plan displays on the correct dashboard. Now, we've pre-located the 2021 hurricane names, so I'll just choose Ida for this demonstration, and then I provide the plan survey date. I'll also include which agency is submitting the plan, and I'll enter a survey team name, a team lead name, and a team lead email. You could also provide mobile contact information if desired, and I do need to specify the data collection platform. Now, here I'll just choose other and say I'm going to use the GPS from my car and phone. I can describe any survey equipment used and provide additional comments. Finally, I click submit, and I receive a message that the data have been sent successfully. When I refresh the dashboard, the flood stage readings will update to current conditions. And now the dashboard reflects my submitted plan. So if I navigate up to New Jersey, I can assess the survey target area. It's shaded based on the agency color. The high watermark planning dashboard allows survey teams to know where the other agencies are planning their collections, really supporting interagency coordination. Because the best tool is the one that's used, and the more it gets used, the more fine-tuning can be done to keep the gears turning smoothly. The high watermark planning dashboard was built last year and has gone through many iterations to find out which capabilities are key. And we're continuing to gather feedback from Athena Clark from USGS Storm Team, Paul McKee from NOAA National Weather Service, Mike Flanagan from the Army Corps, Adam Barker from FEMA, and so many others. This coordination allows us to adapt the tool to fulfill our shared needs. Those 3 dots you imagined at the beginning could be 6 dots if you coordinated with someone, so you knew you were drawing different dots. Coordination is a powerful way to extend your resources. The USGS National Geospatial Program really believes that good coordination supports solid collaboration. Imagine being able to not just extend your resources, but pooling them with others with a shared vision and complementary mission. The 3D elevation program is a great example of solid collaboration across the geospatial landscape that has absolutely been built on partnerships. 3DEP is based on the results of the 2011 National Enhanced Elevation Assessment that was funded by National Digital Elevation Program agencies. The study identified more than 600 requirements for enhanced elevation data needed to address the mission-critical needs of all 50 states, more than 30 federal agencies, as well as some tribal and local governments and private companies. At the end of fiscal year 2021, there are elevation data available or in progress that meet 3DEP specifications for high accuracy and high resolution for 84% of the nation. 84%. We're well on our way to creating a digital twin of the nation's topographic data, both constructed and natural features. All 3DEP products and services are available free of charge and without use restrictions. And these data support many mission-critical activities, from flood risk management, which has such a high national dollar value and societal benefit, to precision forestry. It can aid in wildland fire management, planning, and response. It helps detect air navigation obstacles for aviation safety. Other application areas include archaeology. Just a few weeks ago, the National Park Service reached out looking for the best publicly available data for an archaeological site on St. John in the US Virgin Islands. LiDAR is useful to infrastructure management, which with our aging infrastructure is a growing national concern. It can support alternative energy initiatives. You can use it to determine solar potential. Finally, geologic hazards is a critical application area for LiDAR. It can be used to map subsidence hazards like landslides and sinkholes. And after the 2017 hurricane season, those proved to be significant hazards, especially for Puerto Rico. Here's some NASA satellite imagery showing some of the 2017 storms. First, Irma as a Category 5 hurricane strikes the northern US Virgin Islands and then skims Puerto Rico, causing widespread power outages, increased rainfall that resulted in flash flooding. And the time I was living in St. Petersburg, Florida, and Irma was barreling up the peninsula. My family and I were using every available resource to help us decide if we should evacuate, from storm path predictions to gas apps to show if we'd get stranded on the freeway. And then here comes Maria, a second Cat 5 hurricane in less than a month, and her impact was devastating to already saturated ground and damaged infrastructure. A few months after the storm, we had the chance to visit St. Thomas and meet with the Office of the Lieutenant Governor's GIS Division. And I remember being on the ferry to St. John when a resident shared that since Irma had taken out many of the comm towers on the islands, they were actually starting to unboard their homes before they received news that Maria was not far behind. Here's a LiDAR-derived image of Puerto Rico after Hurricane Maria. Now, during that visit, I remember being struck by the sea of blue as we were flying into San Juan, but it wasn't the water. It was the sea of blue tarps still covering many of the roofs. It's vital to highlight the hazard applications of open data sets, such as the 3-depth LiDAR. This image is an example of how elevation data can aid in sinkhole extraction in karst terrain. GERT is collaborating with USGS scientists for a science application for risk reduction project, which focuses on building partnerships to improve the use of natural hazards information. In this image, you can really see the cone and cockpit karst. In the south part of the image, the classic cone-shaped limestone hills really stand out. And as we transition northward, a sinkhole plain underlies a mix of agricultural and urbanized areas. The scientists are extracting sinkholes from the 3-depth LiDAR in a semi-automated fashion using ArcGIS Pro, and it will result in a geodatabase of sinkhole feature classes, relevant geometric attributes of each feature, a density raster to show areas of greater clustering of sinkholes, which is indicative of higher susceptibility to subsidence hazards. Once we have those results, GERT is going to create a public ESM focused on karst hazard mitigation to provide easy access to the resources and aid in visualization. These LiDAR data sets can support so many hazard applications. USGS researchers from the Landslide Hazard Program attributed more than 40,000 landslides being triggered in Puerto Rico due to Hurricane Maria's intense rainfall. So let me show you one of the ways to find out what elevation data are available. The U.S. Interagency Elevation Inventory is a great example of multiple agencies collaborating with a common goal, which is to get our data into your hands. Let's zoom to Puerto Rico and find out what LiDAR data are available. I'll filter for topography, topobathymetry, and bathymetry for the past decade. Let's also filter for data that are complete and that you can access. Nine out of the 418 data sets in the area meet those criteria. We have the post-Hurricane Maria topo data. We have coastal topobathy collected by Army Corps for FEMA. We have the pre-Hurricane Maria topo data. We also have coastal topobathy collected by NOAA's NGS and some collected by Army Corps' National Coastal Mapping Program. If we click on one of the dataset records, we can view collection dates, status, year, where to access, links to additional metadata and other resources, a link to visualize the data, links to the entwined point tiles if they're available, record owner, contact information, 3-depth quality level. We've got vertical accuracy, horizontal accuracy, the datums, both vertical and horizontal, what products are available, if there are any restrictions, and more information. And if we want to view all of the footprints in this area that are included in the USIAI, we just need to clear the filters. A great example of leveraging the best available elevation data sets comes from the Coastal National Elevation Database Applications Project. Koned is combining these data sets into seamless topobathymetric digital elevation models to create an impactful geospatial product that can be used for coastal storm modeling and so much more. As part of the 3D Nation vision, the Koned Project is collaborating to build these integrated models with the USGS National Geospatial Program, NOAA, and the U.S. Army Corps of Engineers through the Interagency Working Group on Ocean and Coastal Mapping. While the three agencies serve as working group co-chairs, look how many additional agencies are members and a vital part of the collaboration. The IWGOCM is charged to facilitate the coordination of ocean and coastal mapping and to avoid duplicating those mapping activities across the federal sector, as well as with state, industry, academic, and non-governmental mapping interests. This can help support initiatives such as Seabed 2030. Maybe you've heard the slogan, map once, use many times. Well, one of the ways to do that is through solid collaboration, so you know what data have been collected or are in progress or are planned. Coastal mapping summits are a great way to engage stakeholders to share this information. Florida has held a few coastal mapping summits as part of the Florida Coastal Mapping Program. FCMap's an initiative between the state, federal agencies, and academic institutions with a goal to map Florida's seafloor gaps in the coming decade. The Florida Fish and Wildlife Research Institute built an ArcGIS hub to host FCMap data and resources, including a story map that was originally compiled by the Florida Geographic Information Office. Let's take a look. This is a powerful visual tool to explain the purpose of FCMap to stakeholders and residents. It includes a why FCMap, project overview, prioritization, technology and data, as well as a funding section. Of particular interest to this group is the prioritization section that talks about the effort and the GIS tool. It starts by explaining that 5 public workshops were held across the state where we had over 200 attendees from Florida's water management districts to federal, state, and local governments to academics, and they all learned about the prioritization tool and how to use it effectively. We've got additional workshop materials such as a draft agenda. We even leveraged online tools to streamline the registration process. Now, NOAA's National Ocean Service developed a prioritization participatory GIS tool using Web App Builder for ArcGIS to collect the where, the what, and the why. And they worked with us to tailor it for Florida. Here's the prioritization based on all of the information we collected. And we can click on cells. This one shows that there are 34 coins, and the stakeholder placed one and listed general knowledge gap as their primary justification. In the same cell, the next stakeholder placed 4 coins and listed resource management as their primary justification. We can choose another cell. Again, we can review stakeholder justifications as well as what map products are desired. Jumping back to the hub, we have also the organizational chart for the FCMap Science and Technical Advisory Committee with the current chairs and member agencies listed who have been instrumental in this effort. We can also find the vision statement, regional coordination information, and program information. Moving to the resources tab, we have more background about the effort, including the draft prioritization results that are part of a new manuscript that was just accepted. And once that's published, that'll be linked from the hub as well. There are maps showing the prioritization by top percentile and primary mapping needs, ancillary data types, and cluster analysis results. There's a section on the FCMap community, including recordings of the previous FCMap summits. There's even information about the 2018 workshop, including a link to the white paper. Moving to the data tab, we're provided many different maps showing the results of the statewide prioritization index by respondent and cluster analysis, data needs, ancillary data, workshop regions. There are feature layers with different views by 5th and 10th percentile. The top 4 priority categories of data needs. The top 4 priority categories of ancillary data types. The prioritization cluster analysis data. There's even the FCMap mapping priorities index map with regions, and it's interactive. There's the seafloor mapping inventory gap analysis data that are available for download. And finally, there's contact information if you want to connect with FCMap. 3DEP, IWGOCM, FCMap. These are all great examples of solid collaboration because the agencies working together have a common mission and shared vision. With all the data, products, and services that result from those collaborations, it's especially important to communicate to others what's available and where it can be accessed. I encourage you to share what data you can. Communication is critical when supporting hazard response because time is of the essence. Actionable information and authoritative data are vitally important, and knowing where to find them can save precious time. If we hop back to the hub, we have a few more internal and partner ESMs from previous years before we get to the public ESMs that allow us to communicate the available geospatial products and resources to a broader audience. First, we work with USGS Mid-Continent region to support the Mississippi River Cities and Towns Initiative, and we've built an ESM for the mayors along the river corridor. Next, we recently tailored our internal Water 2021 ESM for the public to provide access to many federal geospatial resources during and after a water hazard event. Let's first visit the MRCTI Viewer, and then we can check out the public ESM. The USGS built the MRCTI Disaster Prediction and Assessment Portal to support timely response and mitigation of natural hazards when and where possible, while providing the mayors of the Mississippi River with a communication tool to share critical information with emergency managers as well as their constituents. Tab 1 introduces the initiative and also provides links to MRCTI partners. Tab 2 launches the Stream Gauge Flood Stage interactive dashboard with an expandable legend showing current stage information of major waterways. Mayors can zoom to a specific city using a dropdown or similarly select a gauge, and these can also be filtered to only show those at certain stages. Tab 3 launches the Imagery Explorer, where pre- and post-event imagery can be compared. Let's zoom to New Orleans, since we know Hurricane Ida impacted that area. And we'll focus on an area a little to the east. Using the layer selector, I can set the left image source for a Sentinel-2 view from a few days after Hurricane Ida's landfall. Let's choose September 2nd, 2021. Now, we could leave the right image source as the base map, or we may want imagery from just before Hurricane Ida hit. So let's set the image source for a Sentinel-2 view from August 23rd, 2021. By dragging the slider back and forth, we can compare before and after imagery for this area. Talk about an impactful visual tool for the mayors, those emergency managers, or the residents. Tab 4 provides a disaster imagery archive map. 5 has forecasts and warnings. 6 has nutrient gauge readings from the American Queen steamboat when it's running. 7 has ecosystems information. Tab 8 provides a link to the US Drought Monitor. Tab 9 launches the Recent Earthquakes Pager Events dashboard, where mayors can zoom to their city and filter significant events to show those occurring within the last 7 or 30 days. Tab 10 provides access to US topo maps. There's also a link to National Map download and the USGS Topo View site. Finally, Tab 11 provides information about the Mississippi River Plastic Pollution Initiative. This is a partnership between the mayors of the Mississippi River, the United Nations Environment Program, and the University of Georgia to combat plastic pollution along the river. Here we're accessing the debris tracker that shows upstream and coastal litter collected through citizen science using a free mobile application. Zooming into Baton Rouge, we can visualize the individual debris data, a hard plastic fragment, a food wrapper. Tab 11 also provides links to the initiative, the debris tracker, data that can be downloaded, and also provides information on how to join the initiative. Because the plastic pollution in the Mississippi River can flow right into the Gulf of Mexico. Having these geospatial resources in a story map format is a really effective way to communicate what tools and data are available while making it easy to keep it refreshed with any new initiatives for the mayors. Next up, we have the public event support map. This tool allows us to communicate with the public, demonstrating how USGS science can help communities better understand the implications of change, anticipate the effects, and reduce the risks associated with a changing environment. We combine USGS resources with those from other agencies. Tab 1 opens to the Water 2021 web map that defaults to show the USGS and the flood and high flow gauges, and we also have any NOAA tropical systems. We could also turn on other layers, such as arts and culture institutions. That's a collaboration with FEMA DHS and the Smithsonian, or you may want to add your own data to the map. The other dashboards linked from Tab 1 are ones we covered earlier, so let's take a look at Tab 2. It provides USGS water support applications, such as the USGS Water Watch showing current stream flow, drought, flood, and past flow runoff information. Additional links under Tab 2 include the National Water Dashboard. This is where you can view real-time water data in context with current weather conditions, as well as hydrology. The Coastal Change Hazards Portal is where you can view potential coastal change impacts during storm landfall, such as the probability of storm-induced collision, overwash, inundation, elevation of the dune crest, the dune toe, mean water levels, extreme water levels. There are links to other resources as well, such as the USGS Flood Event Viewer, the Flood Inundation Mapper, and USGS Project Alerts. Tab 3 provides links to many mapping and data resources, so let's just take a look at a couple. Here's the USGS 3D LiDAR Explorer that leverages the power of 3D visualization and cloud optimization. Let's check out St. Croix in the USVI and view the end-to-end point tile format using the Poetry Viewer. This viewer allows users to visualize the LiDAR point cloud and adjust many settings and access many tools before pulling the data to your local machine. I can display by the intensity attribute, or maybe I want to see elevation. I can change which classifications are displayed. I can then tilt and pan and zoom. It's a powerful way to visualize and explore the data before downloading it. Tab 3 also links to the USGS National Map Viewer, where you can visualize many layers, including a variety of national land cover database layers, such as canopy cover, shrublands, the 3D elevation hillshade, the 3D tinted hillshade, the 3D aspect map, even a geologic map of North America. There are links to data download as well as to services. Tab 4 provides links to NOAA resources such as the West Gulf River Forecast Support Tool, the National Hurricane Center, the National Weather Service, the NWS Web Map, pre-event imagery, HURAVAC, and more. 5 links to NASA resources, including the NASA Disasters Portal and practitioner resources. 6 links to FEMA resources, the Geospatial Resource Center, the CAP Imagery Viewer, the National Risk Index. 7 links to Army Corps resources, including their Geospatial Open Data and their Jobble Text Volume Change tool. Finally, Tab 8 provides links to training videos on how to use National Map products and services and tweets about the Hazard Data Distribution System imagery collections. 8 tabs of geospatial data from multiple agencies that can be used to help support resilience, all communicated through a story map. Here's a great communication tool from the USGS Pacific Coastal and Marine Science Center and the University of California, Santa Cruz. Their study highlights the protection value of coral reefs for risk reduction in the face of tropical cyclones. Using computer simulations, the scientists modeled the flooding from different storm conditions all along the reef-lined shorelines of the United States. They used both current reef characteristics as well as degraded characteristics with varying storm return intervals to simulate the 10-year and other storm conditions. They quantified the results using the latest information from the US Census Bureau, FEMA, and the Bureau of Economic Analysis. They found basically that losses would double if the coral reefs were degraded, even by a meter. Science like this can be used by decision makers and stakeholders to help increase coastal resilience. And it's not just coastal resilience where our data and tools can help. GERT's newest tool that's in development on Geo Platform leverages Experience Builder to communicate near real-time situational awareness to resource managers. It shows at-risk facilities, seismic stations, and stream gauges with relation to wildland fires. On October 25th, I clicked on the Sequoia Kings Canyon Field Station to better visualize the KNP complex fire in relation to the facility. The second tab allows facility status reports to be submitted online through the tool. You just click on a facility from the list, or you could pan and zoom to one on the map, and then complete the report information. The third tab allows those reports to be viewable by facility managers and regional and bureau leadership. Back on the first tab of at-risk assets, managers and leadership can additionally view near real-time indicators of threatened, active threatened, and total counts of facilities, earthquake early warning seismic stations, and stream gauges within proximity of a wildland fire. Remember that the core GERT members come from the USGS National Geospatial Program User Engagement Office, where we have a network of liaisons and focus area coordinators all working to identify outreach and partnership opportunities. The User Engagement Office strives to connect users to the various NGP geospatial data, products, and services. We're constantly gathering feedback on these, especially for the national map. This lets us work to ensure that any future developments meet the USGS and department science objectives, allowing us to provide the greatest value and impact for the nation. So I encourage you to reach out to your National Map Liaison to learn more about 3DEP and the other national map products available. At the USGS, we coordinate across teams and projects. We collaborate with other mission areas and regions, and we all work to communicate our science. I just showed a few examples of our work, so imagine what else is out there. Because while our products are designed with scientists and other governmental users in mind, with the hope that it will lead to regenerative and sustainable solutions for the future, all of our geospatial resources are valuable to a broad range of users. Maybe you're a natural resource manager or a planner. Maybe you're a student looking for data to support your research project. Or maybe you just want to get outdoors and go for a hike, visit the beach, canoe through mangrove trails, or snorkel to check out a coral reef. Just as the Earth is a collection of vibrant and dynamic ecosystems and landforms, we, the GIS humanhood, are made up of an astounding variety of skills and expertise and perspectives. Maybe you're coordinating because you need more data, or maybe you're collaborating because data sharing is your focus. No matter what, I encourage you to be communicating. We're fortunate enough to be part of an industry that has innovative tools to help us while helping others. Together, we can help transform the world using GIS. We all have a stake here, and we must work together to ensure there are more tomorrows than yesterdays. Maps offer a common language. I was imagining LiDAR data when we were drawing all those dots. Imagine the power of connecting them like words to convey thoughts and provide more complex information in sentences that can tell a story to help others understand, to help others see so they can believe. Imagine how much impact we could have. So connect the dots and share your story. No story would be complete without characters. Here are some from my story that I'm grateful for, along with many more. Thank you so much.